Hello everybody, welcome to our student design presentation. My name is Mark Belisario.
I'm Nick Mahold.
I'm Jack Winter.
Today we're going to be talking about the CPSS phase identification system. Nick, take it away.
So for a little background, Mid-America Energy came to us to design a system that would identify both phase and circuit. So we came up with a solution like this, which measures the magnitude and the phase on the wire. The distance between the manholes or the points of measurement will be about 2,000 feet, so we need a wireless method of communication to send the data from one to the other.
A little project overview. Both devices will have two Rogowski coils to act as current probes. The signal coming from these Rogowski coils will go to two different circuits, a zero crossing module for phase identification and a RMS to DC magnitude measurement circuit for our magnitude measurement. The data will be communicated across via a RF communication, and we'll also be using a GPS timestamp to synchronize these data points.
So in this project we actually use a lot of electrical engineering. We did anything ranging from modeling the power cables to ensure there's no phase shift in those 2,000 feet of distance between the manholes. We also did a lot of analog design, so anything like the zero crossing modules, the RMS DC module, the power supply, and we also spec'd out a battery. We also did we programmed the microcontroller to get all those analog values, interpret them, and send through an RF module. We also interpreted all that with a GPS module too. We designed a PCB, and one of our team members had a 3D printer, which we used to design two cases.
Some of the main specifications for this project is that the two devices should communicate wirelessly up to 2,000 feet. The magnitude must be accurate up to plus or minus 10 amps RMS and have a resolution of 1 amp RMS. The phase angle must be within plus or minus 10 degrees and its resolution of 1 degree. The battery should last at least 2 hours. A device must be handheld and portable.
To demonstrate the capability of the system, we have two Rogowski coils. One is going to the reference device on the left, and one is going to the master on the right. Currently, they are measuring the same circuit, same phase. They're both on phase A. And you can see here that the master is showing about negative 10 degrees phase shift between the two. Now, it does vary a little bit. You can also see that the magnitude here on the left for both they're very close together. There is some difference between the Rogowski coils.
Right, so now we're going to test out our different phases. So we actually connected one of the Rogowski coils in phase A, one of the Rogowski coils in phase B, and as you can see, the phase difference between the reference and master is about the 120 degrees that is expected.
Currently it says negative 140. There is some coupled inductance between these coils, which can throw off our measurement in this test setup.
Going back to our specifications here, we did meet our first bullet. So we tested our wireless communication module outside and we got to up to 2,300 feet. Our magnitude was within the plus or minus 10 amps RMS. The resolution was of 1 amp RMS, which basically means that there was no decimal points. The phase angle was within the plus or minus 10 degrees of the predicted phase, and the resolution was also of 1 degree, which basically means that there's no decimal points. We chose a very large battery on purpose. The customer wanted a drill battery to be used on the project, so our specification of 2 hours was met. we actually got our calculator their device should last over 40 hours of a single charge. The device was handheld and portable, both of them. Thank you so much for watching and for your time. Please let us know if you have any questions.